This is a modified Softrock ensemble. The gain of the op-amps is reduced by about 10 dB and phase noise on the local oscillator is removed by use of a couple of capacitors. With this attenuator put in 0 as it is now, the signal level on the input connector is -8 dBm. I'm here running lead rod with a modified Delta 44 and it's set in the +4 gain position because that makes the noise for the lowest. But the input circuits are adjusted to make the signal level match the maximum level of the Softrock reasonably well. It means press A, the signal is 1.8 dB from the point of saturation. Here is the main spectrum. It looks pretty clean. And I step the frequency in steps of 5 kHz. 5 brings the noise floor down to -120 dBm. It was set to -8, which is the signal that we send into the unit when it was tuned to that signal. And 5 more kilohertz. Doesn't change much. Now 20 kilohertz from the selected frequency. That's the separation where we normally measure dynamic range. So I look for the noise floor here and find -121.4. And now I step upwards in steps of 5 kilohertz, looking for possible ugly things. But what I see is just that the noise floor goes down. And looking at the main spectrum, I don't see any unpleasant things. Now we are 60 kilohertz above the signal. I remove the signal like that. And you can see reciprocal mixing is something like 2 decibels or maybe 2. And now the strong signal is back and I continue stepping upwards. Oops. It's easy to click inappropriately. What I can see is that there are no reciprocal mixing problems in this Delta 44. It is a modified board and I don't remember how the original one behaves, but the noise level is pretty much higher, so the reciprocal mixing is probably hidden. Anyway, this is what I see. 121.4 at 20 kilohertz. For completeness, I sent -18 dBm into another Softrock ensemble, which is in its original shape. And it needs this capacitor. I have calibrated it now to show Sorry, I should find what this bug is and correct it someday. It's calibrated to -18.0, which is the signal level we have. Then I switch off the generator to read the noise floor with the modified Delta 44. The modification is described in detail in one of the earlier videos in this series on Softrock ensemble that I'm making. The noise floor is -127.8. I'm now using the sound card of my Supermicro X9Dai. It has a Realtek HD audio chip or chipset on it. The signal level is -18 dBm into the original Softrock, and I have set the S-meter to show -18 dBm, and I switch off the signal generator to see where is the noise floor, and I can read it out after a short period of time. From here to here. No, I have to wait. From here to here. -126.9. I'm now running the X9Dai motherboard sound card on the modified Softrock unit. And here is the main spectrum. The S-meter graph is calibrated to show -8 dBm, and that's the signal level I'm sending into the unit. And I step the frequency upwards in steps of 5 kHz. 5 kHz, 10, 15, 20 kHz. That's where I take the reciprocal mixing noise floor. If nothing else turns up that makes me decide there is a problem where the noise floor is far too high, and that should be noticed and a problem for the sound card. And someday I will have to do something about this readout problem that works only now and then. -118.95, that's -119. And actually there is some fairly narrow noise spur at this particular frequency. It might be unfair to go here, so I move a little bit outside. But it doesn't make much difference. -119.3, let's say that. This dongle needs a driver that you have to download as shown in an earlier video. With the default drivers of Windows, performance is lousy. One has to set the volume control to the absolute minimum, the very last pixel here before it becomes quiet. And then the sensitivity is still too high. Some attenuation is needed, actually 3 dB. Well, maybe it is now it is visible. So the level into the unit is now minus 11 dBm. So I calibrate Linrad to show minus 11 dBm, and that's with the modified Softrock that can take this kind of signals. And I step the frequency 5 kilohertz, and that's the noise floor. 10 kilohertz, 15, 20 kilohertz away. And this is where I normally measure the level of the noise floor in the reciprocal mixing testing. So it is from here to here, minus 111 dBm. That's the reciprocal mixing noise floor, and when I switch off the signal, means attenuate it very much, you can see there is no difference. So this is not reciprocal mixing, it's the noise floor, the unit itself. And I will step further away in frequency to see if there is some oddities that we wouldn't like to see. And the main spectrum looks nice, and I see no particular problems. Well, I can see a spur coming in here. It doesn't happen to come right within the 1 kilohertz passband, but a couple of spurs isn't really a problem in SDR, because we could change the LO to not make them interfere with the desired signal. So I don't see any horrible problems. This is some kind of noise spur. You can see we have a lot of nasty things, and you can see in the waterfall something of that comes within the 1 kilohertz, but it doesn't contribute more than about 2 dB, so I ignore it and step again 5 kilohertz. Oops, like that. And you can see it moves a little bit. So this could be a problem in some circumstances, but I take the value minus 111 for this sound USB dongle. Now I'm using the motherboard sound card of this D5400XS Intel board. It's a Sigmatel or IDT 96 kilohertz 24-bit sound card on the motherboard. Under Windows XP with the MME drivers I can only get 48 kilohertz sampling speed. Well, I have 96 kilohertz, but it's upsampled from this central region. These things go without announcing what they are doing. This is the sound recording configuration, and there is no advanced where I could set a different sampling speed. Using port audio I can probe the sound devices, and I find here that the IDT Audio 1 only has 48 kilohertz for all the different devices I can choose. So I have to leave Windows XP 32 and go for a more modern version of Windows. With the gain set to 0, I have to reduce the signal level from minus 8 dBm to minus 11 dBm into this Softrock to not saturate the internal sound card of this computer. the margin to saturation looks like 2 dB, but if I add 1 more dB of the signal level, this is what I see. And it is not the full range of the AD, but it goes very badly nonlinear. So the maximum signal level here is minus 11 dBm. And I have set the S meter to show minus 11. I hope there, minus 11 dBm. And now I step the frequency 5, 10. So there is a spur. We have it here. I can just get rid of the spur like that, and you see there is nothing remarkable. 15, 20, and the noise floor we have with this motherboard sound card is minus 117.1, and I go upwards in frequency to see if there is any unpleasant surprise somewhere. And looking here, so the sampling clock, as well as the voltage on the reference to the ADC, seem to be noise free. So reciprocal mixing comes at minus 117.1, but if I switch off the strong signal like that, you see there is no change, which means that what we have is not reciprocal mixing, it's just the noise floor of the ADC. I have added a 3 dB attenuator in the audio line from the modified Softrock ensemble, and now I can send minus 8 dBm into the unit without any problems. And I have calibrated the S meter to show minus 8 dBm on the signal, and now I step upwards in frequency again. 20, sorry, now it's 20 kilohertz away, and I wait a little while to read the noise floor. Minus 114 dBm. And I continue. Well, I can switch off the strong signal to see whether this is reciprocal mixing or just the sound card noise. And now the signal is gone, or at least very weak. And you can see the noise floor didn't change. So this is not reciprocal mixing, it's the sound card noise. And I can go upwards to see whether there is some surprise. Not very likely, because the difference from before is not many dBs. So the motherboard sound card on this computer with a 3 dB audio attenuator gives me a noise floor of minus 114 dBm with the point of saturation as minus 8 dBm.